Right. So, shall we start? Okay. So, welcome to this second session on Octave for mathematical physics. So, the previous session was seen about entering data and processing basic matrix operations and plotting basic functions. So, now we're going to see in detail about graph plotting. Okay. So, we're going to use this editor to input the instructions and see how do we process. Okay, so I'm trying to plot all sine, cosine, trigonometric functions and a few whatever given in the syllabus. So for that purpose, I'm considering data points starting from. So you have to open the editor first of all. Okay, so open the editor and enter x equal to 0 to 0.12, 2 star pi up to 2 pi, so that I can see at least one cycle of the ah, చెప్పండి. editor. Okay. Mm-hmm. Okay. Now window calls my event and I select this. Okay. థీమ్ డార్క్ థీమ్ నుంచి చేంజ్ చేయాలి, అదర్వైజ్ ఆప్షన్ బి దీని ఫాంట్ సైజ్ పెంచి. సరిపోదా? కంట్రోల్ షిఫ్ట్ ఏంటంటే అక్కడ విండోలోకి వెళ్ళి షో ఎడిటర్ అని సెలెక్ట్ చేయండి. Octave GUI already open అయ్యింది ఇక్కడ. Octave GUI search. Octave GUI OCT. Type చేయండి. Okay. Okay. Go ahead. ఫాంట్ సైజ్ పెంచండి. థీమ్. చెప్పండి. యా, ఎడిట్ ప్రిఫరెన్సెస్, లాస్ట్ కమాండ్ కమాండ్ 20 చేయండి. అది లాక్ అయిపోయింది. బోల్డ్ ఓకే ఫస్ట్. ఓకే ఓకే. ఎడిటర్ లోవి Ctrl+Shift+. కొట్టు. ఓకే, ఎడిటర్ లో Ctrl+Shift+. కంటిన్యూ చేయొచ్చా? వ్యూ విండోస్ లోకి వెళ్ళి సెలెక్ట్ చేసి షో ఎడిటర్. ఎడిటర్ Ctrl+Shift+. Okay, right. So we have considered, I mean, x as a variable ranging from 0 to 2 pi with a step size of 0.1. Okay, so now what do we want? Yeah, we know basic plotting. Now try this subplot. Subplot 2 comma 3 comma 1. So it creates a 2 by 3 grid and it considers the first box. Subplot 2 comma 3 comma 1, and within that plot x comma sin x. View Windows look at view editor and show editor. Okay. 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 Now save file. I'm saving it as plots.m. .m tells that the program is a MATLAB code. Plots don't give any built-in functions. I'm saving it as plots, plots, plots.m. Plots.m, plots.m. .m indicates it's a MATLAB file. Control S, save, and the file name is plots.m. .m is compulsory, no spaces. File name lo spaces undakodu. Special characters allowed is only underscore. File names లో స్పేసెస్ ఉండకూడదు. ఒకవేళ మీకు స్పేస్ కావాలి అంటే అండర్ స్కోర్ యూజ్ చేయాలి. No other special characters are allowed. So once you save it, click on the green button, save and run. Control S, save. Green button, green arrow mark. Plots.m, plots.m. సేవ్ చేసేటప్పుడు plots.m అని సేవ్ చేస్తున్నారు. plots.m. Okay. plots.m. Okay. Simple form. Plots. Input column. Okay. Written command. ఆ ఫైల్ డిలీట్ చేయండి, ఫైల్ సేవ్ యాజ్. ప్లాట్ ఫంక్షన్ ఓవర్ రైట్ అయిపోతుంది. plots.m. cannot give a built-in function as name. Plot original function overwrite అయిపోతుంది ఈ ఫైల్స్. Shall we continue? ఫైల్ నేమ్ plots.m అని ఇవ్వాలి. plot.m అని ఇస్తే గనక ఒరిజినల్ ప్లాట్ అనే ఫంక్షన్ ఓవర్ రైట్ అయిపోతుంది మనం రాసినటువంటి ఈ 4 లైన్లతో. సో rename it and delete plot.m file if at all. capital small difference between the two. Sorry, caps of complete caps. Here, plot and size చేశారా delete చేయండి ఎక్కడ లొకేషన్ సి యూజెస్ చెప్పండి ప్రోగ్రామ్ ఏది ఎడిటర్ డాట్స్ డాట్ ఏమో ఓవర్ రైట్ అయిపోయింది రిమూవ్ ఎవ్రీథింగ్ కంట్రోల్ గ్రాఫిక్స్ ఏం చేయాలంటే అంతే అప్పటికి అయిపోయింది నెక్స్ట్ చూద్దాం రైట్ చెప్పండి ముగ్గురు ఒకటే సిస్టమ్ ఓకే కంటిన్యూ ఏమైంది డన్ గ్రాఫ్ వచ్చిందా ఓకే నెక్స్ట్ చెప్పండి ఎడిటర్ ఏది ఓకే మళ్ళీ సెలెక్ట్ చేయండి అది చూడండి అప్లోడ్ కలిగి ఏమైంది could not find plots data for writing access denied okay already exists zero is okay right so the next one I'm taking the next slot subplot 2 comma 3 comma 2 in the 2 by 3 grid I'm selecting second box. Plot x comma cos x. So I get the graph for cosine x. Save and run complete again green button. Wrap it up. A file delete చేశారు plot dot m అని సేవ్ చేసినది. That is how it works. Okay. ఆ plot dot m అనేది delete చేయండి. Delete చేయాలి. Ox dot m ఉంది కదా. Okay. 2 comma 3 comma 1. First option. ఇది చేయొచ్చు కదా. ఇది వేరే అది వేరు కాదా. 2/3 గ్రిడ్ అండి అందులో ఫస్ట్ ది సెకండ్ ది. The total 2/3 grid, your sin x falls in first slot, cosine x plot falls in second slot. Okay, so what are the other functions described in your syllabus? Sin x, cosine x, e power x, log x, x square, and square root x. Now you can plot all of them one by one. E power x, log x, x square, square root x. That is for x square, x power 2. అక్కడ వరకు అయిపోయింది కంటిన్యూషన్. విండో లేఅవుట్. విండో లాస్ట్ ఆప్షన్ రీసెట్. అదే క్లిక్ చేయండి. That's what 2, 3 అనేది 2 by 3 grid. It contains 2 rows and 3 columns. Zero. Oh. What's that? మీరు ప్లాట్ అనేది ఏమైనా సేవ్ చేసి ఉన్నారు ఆల్రెడీ? ఆల్రెడీ రీప్లేస్ చేసేసి వెళ్ళిపోతుంది. క్యాపిటల్ ఎక్స్ స్మాల్ ఎక్స్ తేడాలు ఉన్నాయి. ఓకే, ఎక్స్ జీరో జీరో ఇంటూ త్రీ జీరో. ఇంకోటి కాలమ్స్ బ్రాకెట్స్ మిస్ అవుతున్నాయి. బ్రాకెట్స్ మిస్ అవుతున్నాయి చూడండి. బ్రాకెట్స్ ఏమైనా మిస్ చేశారమ్మా? క్యాపిటల్ రాస్తున్నారు. క్యాపిటల్ స్మాల్ ఎక్స్ ఆర్ డిఫరెంట్. క్యాపిటల్ అది చేంజ్ it. Capital X and small x are different. Classification all out. Six column one error. Spelling mistake. Identical one. 19 column 15. If you did not get any graph, check the command window for any error message. పర్వాలేదు మెయిల్లో పెట్టినా సరిపోతుంది. మెయిల్ అయినా ఓకే. And, okay. Control shift plus. Control shift plus. Control shift plus. Okay. Plot dot మనం సేవ్ చేశారా? ఆల్రెడీ ఎగ్జిస్ట్. ఓకే. ఆ ప్రీవియస్ ఫైల్ డిలీట్ చేయాలి. ప్లాట్ డాట్ అనే ఫైల్ ఉండకూడదు. ఓవర్ రైట్ ద ఎగ్జిస్టింగ్ ఫైల్. గ్రిడ్ సైజ్ అండి. మనం ఎన్ని ప్లాట్స్ సబ్ ప్లాట్స్ ఎన్ని కావాలంటే యా 2 rows 3 columns. అందులోంచి ఫస్ట్ది, అందులో సెకండ్, అందులో థర్డ్. కంటిన్యూ చేయొచ్చా? ప్లాట్ డాటా మనం సేవ్ చేసి ఉన్నారు ఇందాక, ఫైల్ డిలీట్ చేయాలి. క్లోజ్ చేసి ఓపెన్ చేయండి. స్పేస్ తగ్గించండి, 0.1 పెట్టలేదండి. ప్లాట్ డాటా మనకు ఫైల్ ఏమైనా సేవ్ చేశారా? ప్లాట్ డాటా డిలీట్ చేయాలి. Now we can add labels and titles to each plot. Plot data మన old file ఏదో ఉన్నది అది delete చేయండి. Right. So you can add so title title. So when you start typing, you get suggestions for possible commands. Title single quotes, sign of X. X label label. So when you start typing, you'll get the suggestions for the list of commands available. YLABEL. Title TITLE. Label LABEL. Complex ఉంది మిగతా స్మాల్. Okay.
Now we are putting the names for x-axis and y-axis.
Suppose for x square, okay. The next one, so to know the further possible options available with plot, type this help plot. So any command, details can be viewed through this option help. Help plot. Help plot will see the usage of the function. Solo option is not working here. Okay. So anyway, so that help plot option gives you how to use that function. What are all the options available? Like to specify just dash, it gives you solid line, double dash, dash line, colon, dotted line, dash dot line. You can control the markers, plus, circle, star, point, cross. Markers can be controlled, color can be controlled, K for black, R for red, G for green. So you can verify that through that option help plot. Okay. Let's say you can, let's say if you want red color for this sin x, plot x comma sin x, single quotes R. That graph comes as comes in red color. Red color, and if you want dash line, within the same single quotes, double dash for dash line. If you want a marker circle, so all points are represented by circles, and the line is a dash line. Sunshine, green one. Sunshine. Group is in elements is commandment. Certain line 5 are important. Line 5 lemon included. Shell. Quotes close shell. Picture. How works? not 0.
Bonus.
Okay.
Okay, sir. Common.
Okay. Shall we continue to the next one? Right. All right. So next one we'll see what is the other one? Syllabus. Visualizing vector fields, solving simple equations. Okay. We try this Fourier series. We try this Fourier series. So what does this Fourier series say? So the Fourier series says any finite, continuous and single valued function. So it says any finite, continuous and single valued finite, continuous and single valued function can be represented as sum of sine and cosine functions. So the conditions are the function should have only finite values and there should not be any discontinuities, should be continuous and single valued. So let's say if you take a square wave, the values are finite, it is oscillating between -1 and +1, values are finite, continuous, there are no breaks in a square wave, and single valued. Take any point on the x-axis, if you go straight onto the function, you'll get only one value. Let's say if the graph is like S, if it is like S, if the given function looks like S, then you'll get 2-3 values at a particular value of x. So in this graph, you have only single value. When if you consider the square wave only, so the square wave is finite, continuous, and single valued. So this can be represented as a series of sine and cosine functions. So this is the series. So excluding that constants and all, if you take sine n pi x by L 1 by n, odd number summations of all sine functions, sine n pi, you'll get a square wave. Okay. So for that I'm considering, I'm taking new script Fourier series. So I'm defining my values x starting from 0 to 0.1. So I try to look for at least 3 cycles. So 3 star, 2 star pi, 0 to 6 pi. X values are ranging from 0 to 3 times 2 pi. And my n values I have to consider all odd numbers. So let's say I'm taking n values starting from 1 to 10. I mean 1 to 10 with a step size of 2. So n takes the values 1, 3, 5, 7 and 9. Otherwise I can directly, okay. So my function is initially 0. So what is the function? Confirm it. F is equal to all odd number summations over sine nx by n. So I'm initializing my function to be 0 for n is equal to News. Don't see that mistakes. And save it as square wave dot m, square underscore wave. Save square underscore. So it is shift minus underscore wave dot m. Shift minus underscore. Square underscore wave dot m. So okay. కొంచెం ఏమొచ్చింది sine wave. Square wave, square underscore wave dot m. You get a sine wave like that. So you get 3 cycles of sine wave. So if you want to see the individual functions that are adding up, you can add this. Hold all and plot x comma sine and x. Reduce this. You can see how many waves are contributing to this sine square wave. So all these waves added up to give you sine wave, square wave. Line 9 column 1. Close this. And run. Okay. 5, column 3. ఏముంది చూద్దాం error. 5. కాలేదు. Column 14. Ah, ah. Close చేసి ఓపెన్ చేయండి. Graph window. Ah, ah. Name, where. Ah, ah. ఆలోచిస్తాను. error ఏంటో చూడండి. Line 3, column 1. Here, go back. Ah, okay. Okay, right. So the other functions, like sawtooth wave, triangular wave, let's say looking for sawtooth wave. That is 1 by 2 minus sin nx by n for all values of n. 1 by 2 minus sin nx by n. So I am copying all this. New script. So now I have to take all the numbers, both even and odd numbers I have to consider, and I have to subtract from 1 by 2. So my initial value of function should be 1 by 2, and each time I have to subtract sin nx by n. So you can save it as a triangular dot m. Triangular underscore wave dot m. That's why I got a triangular wave. So if you want to suppress the contributing waves, this is the triangular wave. I have to subtract all sin nx by n functions starting from 1 to n. I have to consider both the even and odd functions, and I have to subtract from 1 by 2. So here is the function. Which is it? Very close. Same way, you can plot a triangular wave. So triangular wave. This is the triangular wave. Minus 1 power n minus 1 by 2 by n square sin n pi x by L. All odd number summations. Minus 1 power n minus 1 by 2 multiplied by sin nx by n square. So I'm copying the same function, same program. So here the initial value of the function is 0. Again, I have to consider only odd terms. Then I have to add them up. Minus 1 power n minus 1 by 2. So you should be more careful while placing the brackets. The whole n minus 1 by 2 term should be in the power. In the exponential place for minus 1. Minus 1 power n minus 1 by 2. Star sin nx by n square. In angular wave dot m. What is this? Oh, earlier one was sawtooth wave, right? You have a wrong name. So got a neat triangular wave. ట్రయాంగులర్ డాట్, ట్రయాంగులర్ వేవ్. ఇందాక దానికి ఏం చేశారు? సాటూత్ వేవ్. సెకండ్ సాటూత్ వేవ్. ఈ మూడోది స్క్వేర్ అయితే అది ట్రయాంగులర్ కాదు. సర్లే ఓకే, అది అక్కర్లేదు. పర్సంటేజ్ అంటే కామెంట్ దట్ వోంట్ వర్క్. సరే ట్రయాంగిల్ డాట్. సరే ట్రయాంగిల్ డాట్ ఏమని ఇవ్వండి. ఇందాకదే తేడా చేసాము, దట్ వాజ్ సాటూత్ వేవ్. దాన్ని మార్చొద్దులే కానీ దీనికే ట్రయాంగిల్ డాట్ ఏమని ఇవ్వండి. సరే సాటూత్ వేవ్ అండి. సెకండ్ వన్ సాటూత్ వేవ్, దిస్ ఈస్ ట్రయాంగిల్. ట్రయాంగిల్ డాట్ ఏమని సార్ ఒకదాంట్లోనే సేవ్ మార్చట్లేదు. సరే ఓకే. ఇప్పుడు మళ్ళీ మారిపోయింది, కనబడుతుందా? So once if this is done, we'll go for probability. One of the most important experiments, that is verification of laws of statistical mechanics, postulates of statistical mechanics. So that can get better. Like, So our next topic is verification of postulates of statistical mechanics. So it is one of the most important topics. Postulates, Postulates, postulates of statistical mechanics. Right? Postulates of statistical mechanics. So here all natural phenomena that occur in are statistical in nature, are decided by a simple coin tossing. All decisions or all activities of nature are simple coin tossing experiments. Let's say if you write an exam, will you pass or fail? It's a simple coin toss. Some people may pass, some people may fail. So on a average on a whole class, let's say 60% people will get average score, some 20% will get good scores, better scores, and some 20% will get below average scores. So all these things are controlled by the statistical mechanics, a simple coin tossing. So we'll try to simulate that coin tossing experiment in MATLAB. And we try to simulate further how a class average comes out to be a bell curve. So the final outcome, the expected outcome is like so this is how you'll let's say if you have entire class, the average mark, majority of the people, more than 60% of the people will get some average marks. There will be very few people who get below average, and there will be very few people who get above average marks. Okay, this is also controlled by a simple coin tossing experiment. So we try to simulate that coin tossing experiment in MATLAB first of all. So how to toss a coin? I mean, what do we do? Coin tossing. Let's say I toss a coin for 100 times and I count number of heads. So on average, I should get around 50 heads and around 50 tails. Right? So I have to toss a coin and I have to note down whether it is head or tail. Okay. So how to give that instruction to a computer? A coin toss చేసామో హెడ్ పడిందా టైల్ పడిందా అనే ఇన్స్ట్రక్షన్ ని కంప్యూటర్ కి ఎట్లా ఇవ్వాలి అదర్వైజ్ కాయిన్ టాసింగ్ ఇట్ సెల్ఫ్ క్యాన్ బి సిమ్యులేటెడ్ ఎట్లాగా ఎట్లా ఇవ్వచ్చు హౌ టు గివ్ దట్ ఇన్స్ట్రక్షన్ let's say one possibility is you just enter the entire set of 100 data points head tail head tail 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 head 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 like that you enter all 100 possibilities and count number of heads or number of tails. I mean, that is very simple, right? But that's not what we expect out of a robust package like MATLAB. So we have to try to simulate that coin tossing activity also. So one simplest possibility is using random numbers. So open this command window and type rand. If you type rand, it will give you a random number ranging between 0 and 1. The random number value ranges between 0 and 1. Okay, so now I'll generate 100 random numbers and I see if that random number is less than 0.5, I count it as head. If it is above 0.5, I count it as tail. Is that okay? So I'll generate 100 random numbers. And if those random numbers are less than 0.5, I count it as head. If they are above 0.5, I count it as tail. So now, how to generate 100 random numbers? Let's say I try to generate 10 random numbers. So I'll get one row, 10 numbers. There also all are between 0 and 1. So it is 0.1, 0.29, 0.30, 0.68, 0.18, 0.0297 probably. 0.4, 0.8, 0.4, 0.2, 0.2. So I get a set of random numbers, 10 random numbers. Now what I have to do? I have to see, I have to count the numbers between above 0.5, how many are there, and below 0.5, how many are there, I have to count. So let's in this series. Otherwise, I give A is equal to rand 1 comma 10. That sounds good. So now I stored all those in a variable. So now how many heads are there? How many numbers are below 0.5? In my case, it is 1, 2, 3, 4, 5, 6. 6 are below 0.5. 4 will be above 0.5. 1, 2, 3, 4. Your case may be different. So my experiment is success. I got nearly half of heads and half are tails. I got 6 heads and 4 tails out of 10. So if I generate 100, I may get some 58 or 59 heads and like that. Okay, so now I have to count. So V of A less than 0.5 equal to 1. So wherever I have a number less than 0.5, it will be counted as 1. If the number is above 0.5, it will be counted as 0. And the data is stored in the matrix B. So the values of B are defined by A less than 0.5. Now I have to count and plot a histogram. One, two, three. So I got only 9. So I got only 9. Something is missing. Weekend వచ్చినాయి 9 వచ్చినాయి. So I have to define it as B is equal to, in the brackets, A less than 0.5. So this is A. B is equal to A less than 0.5. Now check. B is equal to A less than 0.5. Fine. So B is equal to 100. Sometimes the previous one may not work. B is equal to A less than 0.5. Okay. So now plot a histogram. In my case, I got 4 heads and 6 tails. Five వచ్చిన ఎవరికైనా 6 4 4 6. Okay. Apply. Brand 1 comma 10 first command. Brand bracket 1 comma. A is equal to, sorry, A is equal to brand 1 comma. What next? What is it? Shift to right now, I'll write the program in the editor. So what is that? A is equal to rand 1 comma 10. B is equal to, within round brackets, A less than 0.5. then hist B. The program name I'm giving to this is coin.m. Coins.m. Okay. So I generated 10 random numbers, stored it in A, and I'm counting. If the generated number is less than 0.5, I count it as head. If it is above 0.5, I count it as tail. And I'm plotting a histogram. So now I got 5 heads and 5 tails. Out of 10, 5 are heads and 5 are tails. Coins.m. Coins.m. Coins. So if you check the data, five numbers are above 0.1, 5 numbers are below 0.1. But okay. So up to this part, this is fine. I generated a set of random numbers and counted that if they are less than 0.5, the random numbers, all random numbers are between 0 and 1. If they are less than 0.5, they are counted as heads. If they are above 0.5, they are counted as tails. So now comes the case if I toss 2 or 3 coins. Let's say if I toss 3 coins at a time, otherwise 2 coins at a time, how many heads do I get? I may get 0 heads, means both tails. I may get one head, either head or tail or head, and I may get both heads. So the head count is either 0, 1 or 2. I get 3 possibilities. Now what is the probability? So here I have 2 possibilities, either head or tail. I got equal probability, 50% heads and 50% tails. When I have 2 coins, I get 3 possibilities, 0 heads, 1 head, 2 heads. Then what is the probability? So general prediction says it is 1/3, 1/3 and 1/3. Right? So let's try, or let's confirm it. Let's verify that. So I'm taking 2 coins now. So save it as file, save as coins2.m. Save the file as, save as coins2.m. Now I'm taking, okay. So I'm repeating the first 2 steps as it is for 2 coins. So now I'm taking 2 coins. And instead of 10, I take 100. So that I'll get better results. So I'm tossing each one 100 times. Now what is the probability? The expected probability is 33, 33 and 33. What I'm getting here is 22, 53 and 25. So it is almost like 25, 50 and 25. So instead of 1/3, 1/3, 1/3 distribution, there is something different happening. So now we have to define the postulates of statistical mechanics. Means the governing rules of statistical mechanics. The rule number 1, all microscopic states are equally probable. So all microscopic states are equally probable. That's rule number 1. But here we got something different. They are not equal. We have to identify the reasons. And rule number 2, statistical average is equal to ensemble average. So whatever calculation are done here using probability theory is called statistical average. That should be equal to ensemble average, which means the outcome of the experiment. So when you really toss a coin and get the result, that should be equal to the result predicted by probability theory or statistical mechanics. So these are the two rules. So now we have to see why that probability, we have to confirm whether this first rule is working or is it violated. We have to confirm whether the first rule of the statistical mechanics, is it validated or is it failed in this experiment of tossing two coins. What is that? All microscopic states are equally probable. But what we have got here is 0 heads probability is 25, 1 heads 50, 2 heads 25 again. There is a imbalance. So now we have to confirm that. So now what are the microscopic states and what are the macroscopic states? So microstates for two coin tossing. So what are the possibilities for two coin tossing? 0 heads means both tails, TT. And for one head, it is HT or TH. And for two heads, HH. Right? They are the microscopic states. I mean, when we really go into the experiment and see, these are the possibilities. First coin tail, second coin tail, first coin head, second coin tail. Third possibility, first coin tail and second coin head, both are heads. These are the microscopic states. And what are the macroscopic states? So 0 heads, 1 head. So 0 heads has contribution from this one. 1 head has contribution from HT and TH. And 2 heads has contribution from HH. So now apply the rule number 1. All microscopic states are equally probable. We have 4 microscopic states. So the probability is 0.25, 0.25, 0.25 and 0.25. So when you come to the macroscopic states, as a whole, you see either 0 heads or 1 head or 2 heads. They are the macroscopic states. Now the probabilities become 0.25. Here it is 0.5. Here it is. Because 1 head possibility has got contributions from 2 microscopic states. So that's verified, right? Statistical average. So these are the numbers predicted by probability theory. 0.25, 0.5, and 0.25. That is the statistical average. And ensemble average, when we do really the experiment, the outcome is this. Right? We got 25 0 heads, 51 heads, 25 2 heads. So can you try the same story for 4 coins, let's say? Write down all possible microscopic states and macroscopic states and their probabilities for 4 coins. Let's say now I want to extend this experiment to 4 coins. So this one is clear, right? 2 coin tossing. Now I'm going for 4 coin tossing. So I write the macro states first. What are the macroscopic states? 0 heads, 1 head, 2 heads, 3 heads, and 4 heads. And what are the possible microscopic states? With 0 heads, it is 40s. For 1 head, HTT, TSTT, they are the microscopic states for 1 head. And for 2 heads, HHTT, HTHT, HTTH, THHT, THTH, TTHH. For 3 heads, THHH, STHH. So it will be inverse of the second possibility. HSTH, HHST. Now, how many microscopic states are there total? One, four, six, four, one. This could be the binomial distribution, right? 4C0, 4C1, 4C2, 4C3, and 4C4. So total 16 possibilities. So if I write the probabilities, this has got 1 by 16 contribution. This has got 4 by 16. This one 6 by 16. 4 by 16. 1 by 16. So maybe around 6 for 0 and 4. 4 by 16 means what? 1 by 4. 25%. And 6 by 16, around 35. Okay. So we'll try to write more generic program for that. And I'm saving it as coins 4. So I'm taking for I is equal to 1 to n. N is equal to 4 in this case. I can change that in future. So A of I is equal to rand 1 comma 100 B of I is equal to A of I less than 0.5 not I. Okay. A100 B100. Let us confirm whether do we. Okay. Now we have to add all these. What is it doing? Column wise it is adding. So if I do sum B, what do I get? Each column, all 100 numbers will be added up. Now I do this B. Right. Ncoin.m, whatever. Ncoins.m. Column B. Okay. So we'll work out this in the upcoming session tomorrow. Otherwise, at least we'll write this, we'll extend this and see whether we get A3. This I got around 5, 30, 36, 21, 5. So I should get 6, 24, 36, 24, and 6. So like that, if you extend this number to 10, 15, 20, you'll get the Gaussian function. So this is our class results. If you have 10 students or 20 students, around 60% will fall in the class average level. Around 15 to 20% below average, 15 to 20% above average. So individually, everybody's fate is a single coin tossing, either head or tail, and overall, it is a macroscopic state that decides the overall profile of the distribution. Macroscopic states are equally probable, right? So that's about statistical mechanics, postulates of statistical mechanics. Done. The rest of the things we'll see in the next session.